Step 1. Materials. The required materials utilized in this project include jumper wires, a breadboard with a Raspberry Pi attached, an LED, a Pi camera component, 2 popsicle sticks for the arms, 3 servos for the motors, a monitor with HDMI connectivity to display the environment, a surface or board to apply material, any form of robust adhesive, and at last one clothespin to hold the pen. Step 2. Description of the machine and its features. The entirety of the project is connected to the Pi, which governs every feature and movement of the plotter servos. At its core, the application runs in the Linux operating system kernel and with core Python modules and supplementary libraries such as OpenCV and NumPy. The image files are also stored in the same location in the kernel and can be accessed with an external Pi camera using the Pi camera library. The camera, when accessed, will create a file inside of the image file folder in the kernel as mentioned earlier. When the selected image is processed by the application, it will be processed by the OpenCV library for its detection, and also the Brachiograph library to develop an image.json file and convert such points into angle measures. This will then be accessed by the GPIO pins and processed for printing. With the prototype developed, we can wire up the wires for the machine. Servo motors will correspond with the GPIO pins are shoulder motors, GPIO pin 14, elbow motor, GPIO pin 15, and the lifting motor, which is allocated at GPIO pin 18. These components are wired together using a breadboard that is connected to the Raspberry Pi and servos, which are located on the corresponding arms on an external board. A camera is also used to the designated location, as well as an LED indication at GPIO pin 25 to show when the process has been executed. Step 3. Ideas and full machine explanation. Our ideas for this project include utilizing a lightweight GUI module to connect our components. Additionally, a personalization camera will be added to capture desired images. Another idea for creativity is to add a simple AI module to detect input images. Here's an example of what the final result can be from all of these modules being attached to each other. Step 4. Constraints. The two major constraints in this project are material availability and geometric limitations of the plotter machine. Getting the best results involves understanding the limitations of the hardware and finding ways to compensate for them. For example, the suboptimal materials such as servos and wobbly arms will cause hysteresis. The length of the arms are at 8 cm each limits the maximum reach to be 16 cm, causing undesired marks and smaller prints. The default geometry of the brachiograph and orientations of components could also yield marks or rigid motions. Finally, time is a constraint as the project needs to be completed in a short time. This also makes information harvesting and new skill acquisition challenging. Step 5. Showcase. This is the result of all the previously explained materials, ideas, and description of the machine. It depicts a time-lapse of the printing function for the brachiograph, the final 3 prints, and a supplementary depiction of my face, which was captured using the camera and AI implementations.